Hello everyone, today I'm going to solve this problem. Please pause this video and read this problem carefully. In this problem, there is a collar which is connected with the stretch spring and which is sliding over the rod. You can see that initial position is at A, and with the help of this spring, it will move to the position B. So here mass of this object is 0.9 kilogram and the spring stiffness is given. Now, what is important here, the unstretched length of the spring is 375 millimeter. So it means that at rest position, the actual or real length of the spring is 375 millimeter. To make our calculation easier, we will calculate the length from A to O. It means that at rest condition, the position A, what will be the total length of this spring? So we have calculated the distance A to O by using just simple triangle formula. And so here we can see the stretch total length at position A is 0.875 meter. Now we are going to solve this problem. I will write the mass of the collar is 0.9 kilogram. The stiffness of the spring is given, which is 24 Newton per meter. And unstretched length of this spring is 375 millimeter. It means the actual or real length of the spring when it is in the rest condition. So at position A and at the position B, you can see that spring is in a stretched condition. The collar A will move upward direction because of the spring. So we will apply work and energy formula to know the velocity of point B. When this collar will reach at the position B, what will be the velocity? So we will use simple kinetic energy formula. TA plus UAB is equal to TB. At position TA, the collar is in stationary condition. So we can say that velocity A is 0, so this value will be 0. Now we have to calculate the kinetic energy at position B. So we have to calculate what will be the velocity of this collar when it will reach. It will not, we are assuming that it's not stopping there. When it will reach, what will be the velocity? So we can write half mv square. We have the value of mass m, but we do not know vb. So we will carry out the another process. We will complete the work formula here. So we need to calculate how much work has been done from A to B. When we go back to this problem, we see here that there are two types of work has been done. Can you guess? The first is due to the gravity. When the collar is going up and it has mass, it means that there is a work against the gravity. Secondly, it is clear from the picture that there is a spring. It means there is a work by the spring too. Now when we write mgh, why it is minus? Because we can see that this object is going in upward direction against the gravity, so it will be the minus. Now I will write the formula for the spring work, that is half k x1 square minus x2 square. Now question is why it is plus? Why not negative? What should we do in this type of condition? So there is a simple rule here for the spring. When you are pushing it or pulling it, when a spring goes towards its rest position, the work will be positive. And if we are pulling it or pushing it, and a spring is going away from its position, its rest position, then the work will be negative. The next video I am going to upload about the how to calculate spring work, where it will be more clear. So in this case, a spring is going towards its actual position, because if you see that from position A to the position B, a spring is already stretched and the spring is going to be original, or not exactly original but towards the original position. So we can say that it will be plus 1 by 2 k x1 square minus x2 square. Now I'm going to write all the values minus mgh. Now question is, what should be the h? As you know very well that when we are talking about gravitational work or work due to the gravity, we have to take the perpendicular or vertical height. Okay, so in this case h is shown in this diagram. So we will write the value for h, that is 0.25 meter. Now I am going to solve or write the values for the spring work, and it is clear for us that the work done by spring will be here a positive. Now let's see what is x1. As you know that x1 is initial condition of the spring or spring in this problem, and x2 is the final position of the spring in this problem. Okay, I'm not talking about the rest condition. So at the initial condition, we can find how much is the spring is stretched. So we can say here that total stretch length will be this AO minus the actual or original dimension of the spring or unstretched length, that is 0.375 meter. So the total stretch is how much? 0.875 minus the original length, actual length of the spring. That is, you can write here 0.875 meter minus 0.375. The next is the final position as per this problem at position B. Okay, so in that condition we can write the x, the actual condition in this problem right now is 500 millimeter at position B, and we will minus the unstretched length of the spring, that is 0.375. So I hope x1 and x2 is clear. So now you will put all values in the work equation and you can easily calculate the velocity or unknown here. So here we have calculated the work done from position A to B is minus 2.21, which is equal to the kinetic energy at the position B. So we have already written the formula for TB is equal to half mvb square. So now you can calculate easily the velocity Vb by using this formula here. Vb is equal to 1.156 meter per second.